Dracula's Chivito, the largest planet nursery ever seen. 1,000 light years from Earth, something is forming. Astronomers call it IRAS 2307 7 plus 6707. Everyone else calls it Dracula's Chivito. It is a planet nursery, a slowly rotating disk of gas and dust in the process of building worlds. And it is the largest structure of its kind ever observed in visible light. To understand how large, you need a reference point. Our solar system formed inside a disk, roughly 100 times the distance from Earth to the Sun, across a span that ends at its outer edge, roughly 4.6 billion miles from where everything began. 8 planets, hundreds of moons, billions of smaller bodies, all of it assembled inside that space. A compact space, a quiet one by cosmic standards. Dracula's Chivito spans nearly 400 billion miles. That is 40 times the diameter of our entire solar system. If it were placed where our solar system sits, its outer edge would not stop at Neptune. It would not stop at the Kuiper Belt, the frozen boundary at the far reaches of the Sun's influence. It would continue outward, past every known body in our solar system, for billions of additional miles in every direction, and it would still be the same single disk, rotating around the same single hidden star. But the size is not the most unusual thing about it. One side of this disk carries structures, the other does not. The cause is unknown. We will return to why that asymmetry may matter more than the scale itself. Dracula's Chivito was not found by a telescope pointed at it. It was found by accident. In 2016, astronomer Cyprian Bergea was working through archival images from a sky survey called Pan-STARRS when an unusual shape appeared in the data, 2 elongated wings of scattered light separated by a dark central band. He recognized it immediately, a planet-forming disk seen nearly edge-on from Earth, its equatorial dust blocking all direct view of the star within. He named it after another famous edge-on disk called Gomez's Hamburger, and after his own origins in Transylvania. The faint extensions from the disk's northern edges resembled fangs. It had been sitting in archival data, unnoticed, for years. Long before Earth existed, gravity was already assembling worlds in darkness across this galaxy, entire planetary systems forming, living, and disappearing without ever being witnessed by another living thing. For decades, astronomers assumed all of those planet nurseries were roughly the size of the one our solar system formed inside. Orderly, compact, predictable. Dracula's Chivito does not fit that picture. What do we actually know about it, and what does the data reveal about how planets and solar systems like ours are actually born? When scientists first turned detailed instruments toward IRAS 2307 7 plus 6707, they knew what a planet-forming disk seen edge-on was supposed to look like. 2 bright wings above and below a dark central band, dense dust at the equator blocking the star. The overall shape, familiar, textbook, expected. And that is exactly what the early data showed. The expectation was a large disk, doing what planet-forming disks do, flattening, cooling, settling, building solid material from the inside out in something approaching quiet. That expectation did not survive contact with the data. In February 2024, a team led by Christina Monch at Harvard published the first detailed multi-wavelength study of the system. Radio telescopes in Hawaii measured the motion of cold gas throughout the disk. The result was unambiguous. Every layer of gas is orbiting the hidden central star, inner layers faster, outer layers slower, following the same gravitational law that governs every planet in our solar system. This is not a cloud of gas drifting randomly in space. It is organized, already sorted, already working. Something at the center is in control of all of it. And the material orbiting that hidden center spans at the system's estimated distance, a radius equivalent to roughly 195 billion miles, 70 times the distance from the Sun to Neptune. One side, not the full diameter. The gas is orbiting. Material is being sorted. Something is being built. Somewhere inside that disk, gravity is assembling worlds. In complete darkness, but the rotation data explained only what the disk is doing. It did not explain what the disk looks like. In later 2025, Monch and her collaborators pointed the Hubble Space Telescope at IRAS 23077 plus 6,707, the sharpest eye humanity has ever placed in orbit, and captured images across 6 different wavelengths of light, from visible blue to near infrared. The team expected to confirm the geometry already known from earlier data. What they found in the outer atmosphere of the disk was not expected at all. Above and below the disk's center plane, Hubble revealed wispy, irregular structures, material extending far beyond where the disk's main body ends, visible across all 6 wavelengths simultaneously, consistent across every filter. In other planet-forming systems, faint material above the disk plane has been observed. Not like this. Not reaching this far from the center. Not with this degree of structural complexity. Not this active. The disk's outer atmosphere is not settling. It is turbulent. And it is turbulent in a way the standard models of how planet-forming disks behave did not predict. That explained the turbulence. It did not explain the asymmetry. Stretched outward from the northern edges of the disk are extended filaments, physical structures, reaching thousands of times the Earth-Sun distance into surrounding space. On the southern side, nothing comparable exists. This disk does not look like a calm solar nursery. It looks like weather. Planetary weather on a scale larger than entire solar systems, one side in turbulence, the other side smooth, the boundary between them unexplained. This asymmetry appears consistently across multiple wavelengths, multiple instruments, and observations conducted years apart. It is not a measurement error. One half of this disk carries features the other does not, and the standard model did not predict this. 3 explanations have been proposed. The first, gas from the surrounding cloud is still raining down asymmetrically, stirring one side more than the other. The second, internal density waves. Regions of compressed gas forming inside the disk are distorting the outer atmosphere from within. The third, an unseen second object is orbiting near the system and disturbing the disk gravitationally from outside. None has been ruled out. None has been confirmed. At the center of all of this is a young star that no instrument has ever directly observed. The dust band at the disk's equator, seen nearly edge-on from Earth, absorbs every photon the star emits in our direction. What astronomers know about it comes entirely from indirect evidence. The speed at which the surrounding gas orbits and the heat radiation that leaks through the dust at wavelengths invisible to the human eye. Those measurements suggest a star roughly 1.5 to twice the mass of our Sun, about 11 times brighter, still early in its life, still contracting inward under its own gravity. Some researchers have proposed there may be 2 stars rather than 1. The object that built the largest known planet nursery has never been seen. Every measurement, every image, every data point discussed here was made without anyone ever seeing what is at the center of it. For most of the past half-century, the standard picture of planet formation described a process that was, at its core, orderly. A cloud of gas and dust collapses under its own weight. The collapse flattens into a rotating disk. Dust grains inside the disk collide and stick, growing from microscopic particles into pebbles, from pebbles into boulders, from boulders into bodies large enough for gravity to do the rest. Over millions to hundreds of millions of years, those bodies sweep up surrounding material and become planets. The disk in this picture moves toward order. It smooths, it settles. The chaos of formation becomes, over time, the quiet architecture of a finished solar system. Dracula's Chivito is not moving toward quiet. Its outer atmosphere is active and structurally complex. Its asymmetry is confirmed and unexplained. Its scale places it in a regime where the standard model encounters not just an anomaly, but a physical environment it was never designed to describe. At a radius spanning thousands of times the Earth-Sun distance, the outer regions of this disk exist in conditions most planet formation models were not built to address. Temperatures drop to levels where different molecules freeze onto dust-grained surfaces, altering the chemical recipe of whatever eventually becomes solid. The building blocks of planets in this environment may be chemically unlike anything in our solar system. More significantly, a disk this massive may be building planets through a fundamentally different process altogether. In a large enough, heavy enough disk, regions of compressed gas can become self-gravitating, collapsing directly under their own weight, forming large objects without needing a small core to grow around first. This process can produce massive planetary bodies in thousands of years, rather than millions. We expected the outer edges of a disk this large to be relatively calm. The data shows the opposite. The consequence of that difference goes beyond this one disk, which means the process that built Earth, the process that eventually produced you, may have required conditions the universe does not commonly provide. Our solar system formed inside a disk. That disk is gone, consumed, dispersed, incorporated into the worlds it built. What remains are 8 planets in stable orbits, a belt of rocky bodies, a population of frozen outer objects, and the ancient chemical record preserved in meteorites that have been falling to Earth for billions of years. From that record, scientists have reconstructed a history. Our disk was compact, relatively smooth, and broadly consistent with what the orderly model predicts. The inner rocky planets formed close to the Sunday, the gas giants formed farther out, the orbit stabilized. One planet developed an atmosphere, liquid water, and over 4 billion further years, conditions in which life could begin, persist, and eventually look back at the sky. If disks like Dracula's Chivito are common, and there is currently no data indicating they are not, then the environment our solar system formed inside may not represent how most planets are born. In that sense, we are not simply the product of a planet. We are what happens when a quiet corner of the universe remains stable, long enough for matter to become aware of itself. Earth may not have formed in a typical region of the cosmos. It may have formed in an unusually quiet one. The stable conditions that allowed life on Earth to survive for billions of years may represent a fragile exception rather than a universal rule. Life may require not only a planet, but an unusually long period of cosmic quiet. The universe may produce planetary systems far more varied and far stranger than the one that produced us. The most important unknown about IRAS 23077 plus 6707 is the most basic: how far away it is. The region of space where this disk is located spans a range of distances from roughly 600 to 2,600 light years from Earth. At the closer end, the disk's physical scale is large, but within boundaries some models can address. At the farther end, it becomes so large that it may occupy a physical regime no existing model of planet formation was built to describe. Every number in this video depends on a measurement that has not yet been made with precision. A single careful distance measurement would revise our understanding of this system immediately. The James Webb Space Telescope observes in infrared light wavelengths that pass through dust more easily than visible light. Observations of Dracula's Chivito with James Webb could reveal the thermal structure of the inner disk and the nature of the hidden central star, the measurement that would anchor everything else. The ALMA telescope array in the Atacama Desert has not yet published detailed observations of this system. At ALMA's resolution, astronomers could map internal disk structure down to scales approaching the spacing between planetary orbits, potentially detecting the rings, gaps, and density concentrations that mark the gravitational fingerprints of forming worlds. In 2025, a separate team published the first high-resolution radio maps of the disk, revealing dust with unusual grain properties, steeper than most known planet-forming systems, suggesting that the process of building solid material from dust may already be underway somewhere inside the disk. Each new instrument reveals a layer the previous one could not reach. Here is what the data confirms. IRAS 23077 plus 6707 is a structured, rotating, planet-forming disk around a young hidden star. It is the largest such disk ever observed in visible light. Its outer atmosphere is turbulent and asymmetric in ways that standard models did not predict. Its central star has never been seen. Its distance is not precisely known. Here is what the data does not yet tell us. What causes the asymmetry? Whether the disk is building planets the way our solar system was built, or through a fundamentally different process. Whether the hidden central object is one star or two, whether disks like this are rare or whether they are common and we are only now beginning to find them, the more we learn about how planets form, the less inevitable our own existence begins to appear. If planet nurseries can be this large, this turbulent, this asymmetric, what kinds of worlds emerge from environments like this? And what does the quietness of our own origin tell us about how often the conditions that allowed life to begin on Earth might actually arise in a universe that builds, in places like this, something far more chaotic than what we were born from? Long before Earth existed, this process was already underway in disks like this one, in darkness, without witnesses. We came from somewhere unusually calm. That may matter more than we have yet understood. Life may not emerge wherever planets exist. It may emerge only where the universe grows quiet, long enough for matter to become aware of itself